Folks, welcome back. This is Joel, and in this video we will talk about IPv6 routing. Right, this is basically a continuation to our IPv6 series. We're going to continue using the same topology as previous, and to begin with, let's look at one of the most simplest protocol ever, which is the RIP protocol. Right, so let's write that down. That's going to be the first one which we are going to explore today. So RIPng. Okay, so let's go back to our topology, right? Just a couple of things about RIP, right? I think most of you probably already know, because that's like the first protocol which anyone studies when they look into, routing and switching, right? So it's RS3 based protocol, obviously, and RIPng basically runs on IPv6, obviously, and it exchanges your IPv6 routes, right? The other interesting thing is, in IPv6 you can have a router run up to 4 different instances of RIP, right? So like a multi-instance. We'll check that out as well. So nothing very spectacular about or change with respect to this, because it's very similar to how your RIP version 2, right, with your IPv4. It's very similar to that. So that being said, what we are going to do is in this small segment over here, right? So we've got R4, R5, switch 1 and switch 2. So we are going to go and configure RIP over here, right? And we'll kickstart our IPv6 routing with that. Cool. So let's come here. So let's come to the configurations. Let's come on to my R4, and just to check, right, show CDP enables, we can see that the interface Ethernet 0/1 is the one which is connecting. So what we'll do is, okay, let's actually get the debugs on for RIP. So we'll say do debug, I think it's IPv6 RIP, if I'm not wrong. Yeah, there you go. The debugs are started. Let's just have the debugs running on R4. That should be enough. Apart from that, yeah, so let's get into the interface, which is Ethernet 0/1. But before that, let me show you the current configurations, right? So do show IPv6 interface brief. You can see that we've got an IPv6 address on the Ethernet 0/1, right? That's the only one to be concerned, and maybe for temporarily we can enable IPv6 on the we can enable RIP on loopback as well, right? Just for us to visualize things much better. Okay, so just understand the pattern of addressing here. You can see the 4 at the end. That basically means that we are on R4. Okay. Cool, let's get into the interface Ethernet 0/1, right? With IPv6, the whole network statement is completely gone, right? So we basically stick to enabling the routing protocol under the interface, right? That's what we're going to do. So we can start with, we'll say IPv6, and we'll call the protocol, which protocol? RIP, right? And then you've got to give a name, right? It's a process, right? So you got to give a name. So we'll say RIP version 3, right? Technically RIP version 3 is not there, but I'm just calling your RIPng as RIP version 3, right? Anyway, so we'll just, you can give any name. This is just user selected name, right? I can give anything, and I'm gonna enable that, right? There you go. So that's it. RIP is enabled on the interface, and you can see the interface is starting to send the hellos and all the signaling associated with the RIP protocol. Okay, let's also get and go and enable on loopback 0 as well. Let's enable the same process, right? So we're going to use the same one. There you go. So that's done, and this guy, if you observe, right, it will start sending. Right now it is not receiving anything because we don't have RIP configured anywhere else. So you can see it's just sending, let's analyze this one, right? So it's sending, it basically received its own response. Okay, let's look at this one. So it is sending a multicast update, and you can see the source address is your link local address, and the destination is basically a multicast address, right? It's very simple. You can see the prefix, what it is advertising. You can see there are 2 prefixes it is advertising, because 41 is the subnet on the subnet of that interface where we enabled it, and this one is the loopback address, right? So those are the 2 prefixes it is advertising. Okay, as simple as that, guys. So let's get to switch 1, which is the one which is connecting. If you see here, that's the interface which is connecting. So let's get to switch 1, which is over here, and what we're going to do is very simple, right? So we'll get into the interface, which is Ethernet 0/0, and yeah, let's go and enable the process which we enabled here, right? So where's the process? There you go, that's the process. So let's go and enable that on switch 1. IPv6 is not, oh sorry, my bad. So on the switch, what we have done is we have created, let's look at the switch configuration, show run interface Ethernet 0/0, right? Is that the interface? Yeah, that's the interface. Ethernet, yeah, that's the interface. Cool. So we have put it in VLAN, so and we have an SVI, right? Show run interface VLAN 41, right? So we'll have to enable it under this one. So we'll go and do that. Interface VLAN 41, and let's do what we tried to do earlier, which is this guy. Okay, so we'll go and enable it on the SVI, and we also have a loopback on this one, so we can enable probably there as well. Okay, there we go. That's good. So now that we have done that, this guy will start receiving messages as well. It will start receiving messages. So look at this. This is the, we can actually have a look, right? So I think switch 1 has all its addresses ending with 7. So show IPv6 interface brief. Yeah, there you go, right? Loopback is 7, 41 is 7, everything is 7. Okay. So what is VLAN 41? This interface is in VLAN 41. This interface is in, yes, you guessed it right? It's connecting 5 and 2, so it is VLAN 52. Okay, and these both are also connected in a VLAN, or there is a VLAN running here, which is VLAN 12. So we have 3 VLANs over here, right? Cool. That being said, so we have enabled it on 2 of the VLANs for now, right, on switch 1, and let's look at the let's look if you're getting routes, right? So I'll do show IP route, sorry, not IP, IPv6, right? V6 route RIP. There you go, right? We are getting the loopback address of what? Of my switch 1. Okay. Same thing will be true if I do the show IPv6 route RIP. There you go. So I'm getting the loopback address of R4. Pretty cool. So let's go and do the same thing on what? R5 and R2. So I'll say the same interface here, Ethernet 0/0, and well, let's grab that. What's the name which we are using here? Yeah, there you go. So that's the, let's grab it from here. Okay, there you go. So we're going to put it on that one, right? That's Ethernet 0/0, and we'll also enable it on the loopback for now, right? There you go. That's good. That's done. Let's do it on switch 2. So switch 2, we will go and do the same thing on interface VLAN 52, right? So we'll go and enable that, and the other one will be interface loopback 0 as well, right? So now let's wait for a few seconds, because you know RIP is obviously not the fastest protocol, so it will take some time. But so technically on R4 we should see the loopback of switch 1, and that is what we are seeing already. And on R5 we should see the loopback of what? Show IPv6 route RIP. We should see the loopback of switch 2, and there you go. We are seeing that. That's the switch 2. Anything ending with 8 is your switch 2, right? So there you go. That's good. So what we have done till now is we have enabled RIP here, we have enabled RIP here, right? And we are able to see you know, the corresponding, you know, neighborship coming up and the routes being exchanged. Okay. Now what we'll do is let's try something interesting. So there's a link here, right? And I told you that it's in the VLAN 12, right? Let's see what happens if so what I'll do is, sorry, not this one. Let's go to switch 1. And what's the interface? Let's look at the interface again. It's 0/1, but that doesn't matter. We are going to anyway enable it under the SVI. So what's the SVI? It is interface VLAN 12, right? So on this one, what I'll do is I'll spin up one more RIP process, right? Let's spin up one more RIP process. So let's go here. What's the name? So I'm going to call that as, say, RIP 4, version 4, right? Just for fun, right? I'm going to enable a completely new process. Till now we were using RIP version 3. I'm going to say RIP v4, right? I'm going to enable a completely new process. So how does this you know, impact? What really happens by doing this, right? So but then before that, give me a second, right? Cool. Okay, so where were we? So on interface VLAN 12, I've enabled a completely new process. But what about switch 2? I will go back to switch 2 and VLAN 12, but here I'm gonna, you know, enable the existing old process, right? So there you go. What do you think? What would happen? You know, I've completely created a new process in RIP. Do you think this guy will be able to pair, switch 2 will be able to pair with switch 1 now? Right? So that's interesting, right? So let's check that out. Will that really work? So what I'll do is, give me a second. Yeah. So let's run show IPv6 route RIP on this one, and let's see. On switch 1, I'm getting what? The VLAN 52, which is between 5 and 2, R5 and switch 2. I am getting the routes for R4, right? And I'm getting the routes for R5, and I'm getting the routes for switch 2. So all the routes are available here, though I have spun up a completely new process between these two guys, right? So, I've spun up a completely new process on this one, and you can see that I'm actually getting all the routes, all the routes on switch 1. But the weird thing is, if I go back to say router 4 and let's see what has happened here. Technically, you would expect all the routes to be present here as well, right? But that's not going to happen. You see here. So that's what happens when you spin up multiple instances. What happens is, though you have multiple instances of RIP running on switch 1, they both are completely independent, right? And they will not talk to each other. So we have spun up a completely new RIP on VLAN 12, right? So all the routes which are learned via VLAN 12, which is basically what? The routes which are learned from VLAN 10 on switch 1 are the routes of switch 2 and the routes of R5, right? Basically the VLAN 52 and the loopbacks. So all of those things which are learned from there, via VLAN 12 are not shared or not, leaked into the other RIP process, right? It will always remain in that same RIP process, and it will be available in the routing table of switch 1, but it will not go to R4, right? So that's one thing which I wanted to kind of call out here. Now that we have proved that, there is another interesting thing. What I can do is I can actually go to the same interface, VLAN 12, right? And this time I can actually go and enable multiple routing processes, right? Well, there are consequences. It won't work exactly the way, so let's look at that. Show run interface VLAN 12, what has happened, right? So we have enabled multiple, right? So now you will see some additional routes which might show up in R4. Let's look at that. There you go. One more route came, right? So earlier you see, if I go top here, okay, here, right? So we just had one route, but then now, we have also received the loopback of what? We have also received the VLAN 12, but still we are not gonna learn the other VLANs which is on the other side, which is 52 and the loopbacks of R5 and switch 2, right? So when you basically, I just want to call out that when you spin up multiple instances of RIP, right, or multiple processes, it's not very straightforward, obviously, but you have the capability for doing that if you want to do that. There won't be leaking between the RIP processes, right? So in this case, switch 1 will obviously have all the routes, but obviously the other guys, like in this case R4, you see, you're not going to get everything, right? So let's get back to normal. Now what I'll do is, let me go and disable this multiple instance. What I'm going to do is, let's get here, probably get rid of this v4 which I created, not needed, right? So once I do that, it should clean up, right? So within few seconds, obviously RIP will take few seconds, but after that, right, we should see all the routes, show up here, right? So on. Okay, we don't really want debug anymore, so let me remove the debugs. Okay, it's going to take a couple of seconds. Let's wait. All right, so there you go. We have it now, right? So we just had two routes earlier, but now that we have fixed, we have spun up the same routing process everywhere. You can see we are getting the routes for VLAN 12, VLAN 52, router 5, switch 1, switch 2, right? So that looks good. Okay, so before we go to the next one, what I'll do is, let me just clean up a little bit, which is I really don't intend to put routing on the loopback 0, so let me just get rid of that. So I'm going to say loopback 0, and let's just remove this guy, right, which we have on them. So because I want to advertise that in other protocols, so I'm going to remove that. And on the R5 as well, right, let me get rid of that. Okay, so there it goes. So that's done. So we'll move on to the next protocol. RIP before this. So now we're going to talk about the next protocol, which is EIGRP, right? Just to highlight here in the topology, this is what we did, right? Here we configured RIPng, right, in this particular segment. So now what we're going to do is in this specific segment, which is something like this, right? So in this segment we are going to configure EIGRP, right? EIGRP v6, basically the IPv6 version of EIGRP. Okay, so yeah, let's get to the configuration. There's nothing, since these videos are not very much into explaining how the routing protocol works, it's more about using this topology and kind of like configuring and testing it out and playing around with it. Okay, so that being said, let's get to so if you can have a look at the topology here, we are having R3, R6 and R5, and these both are connected via Ethernet 0/2, and these both are connected via Ethernet 0/0, right? So let's get to it. I think I already have it here open. Yeah, there you go. So so let's get to what? So let's get to probably a couple of interesting things here, right? With EIGRP, there are two different ways of configuring EIGRP, right? I think one of the important thing is knowing the software version really helps. So if I do show version, I think I'm running basically 15.4.2, right? So the releases which you guys are running probably might not be exactly same. Maybe there might be small changes, right? But the basic funda here is that EIGRP with mainly with respect to IPv6, you can configure it in two ways. One is the legacy way, right? And how do we do the legacy way? Let's do that first. So we'll do show CDP neighbors just to again make sure that we are doing it on the right link. So this is the link which we are interested, the link connecting R3 to R6. That's nothing but your Ethernet 0/2. Okay, so let's get into and also let's look at the configuration of that before we configure anything else. So there you go, we have an IPv4 and we have the IPv6 link local as well as the global address on this. Okay, if you aren't sure how to do this, you can go and check my previous videos where we have talked about the whole addressing mechanism of IPv6. Okay, all right, so where are we? Let's get into this interface, which is interface Ethernet 0/2. Okay, and once we are here, what we'll do is we'll do IPv6 EIGRP 100. Okay, all right, so we are directly going to the interface and enabling IPv6 EIGRP and the autonomous number, which is in this case 100. Do you think this worked? Right, how do you verify? So let's do that, right? So let's do show IPv6 EIGRP interfaces. Right, there's nothing, which means what we did just now did not really work, right? And so that's the very important point here with your legacy EIGRP configuration, right, or the legacy way of configuring. You need a global process, right, which means I'll have to come out and in the global configuration mode, I'll have to go and put IPv6 EIGRP IPv6 router EIGRP and the autonomous system number, which is in my case 100, right? So once I do this, right, only then the interface specific command will come into effect, right? So now if I run the same command here, do show IPv6 right, EIGRP interface, you can see the interface has been activated in EIGRP, right? So that's very important with your legacy mode, right? And this is as simple as, legacy mode is very same as what we have been doing for a long time, right? I think you would have studied about EIGRP in your CCNA, CCNP and all those studies, and this is how we literally did it. You have a global process, you put in all the commands under the global process, and then you go to every single interface and you can enable those interfaces in EIGRP, right? That's what we used to do. So that's pretty much how this works. Okay, now let's go to the neighboring router, which is R6, right? And on this one, let me do it via the second option, which is what? Which is the named mode, right? We did the legacy mode, now we'll do the named mode. Okay, so how do you do the named mode? Again, let's have a look quickly to show what is the interface. I think it's okay, let's do CDP neighbors first, right? The interface connecting R3 is 0/2. So let's do show run interface Ethernet 0/2, right? That's what we have. All good. Yeah, so let's get to it. So how do we do the named mode? You go with router EIGRP, and you need a name, right? So you can directly put, I mean, if you go and put your autonomous system, it would basically whatever is the autonomous system. But in my case, we want to go with the name, right? We can use a name here, and I'm basically going to use something like, say IPv6, right? Now this name, what we give here, it's basically locally significant, which means you can use a different name, on the other side as well. Just locally significant, but it's common to kind of retain the same name throughout, so that you don't have any confusion of running multiple processes on different routers, right? Cool. So what are we doing here? So router EIGRP, and we gave a name, right? And once we have the name there, next is we need to go and activate the address family, right? Now, very important point to note here is that this named mode concept is not just applicable for IPv6. You can use this for IPv4 as well, right? And the whole idea behind this named mode is they decided that it gets very tricky with routing protocols, where some configuration goes under global, certain other configuration goes under interfaces. So the routing configuration is generally spread throughout the configuration of the router, right, which is little difficult to track and troubleshoot. So that's why they came up with the named mode. So now going forward, or if you're using named mode, all the configuration relating to that routing protocol, right, will be inside that section itself. So everything will be inside this section, which is, even your IPv4 stuff also will be inside this. So if I put a question mark here, you can see I can configure your IPv4 also using the named mode approach, right? But in my case, I'm gonna go with the IPv6 because that's what we are working on or concentrating here. What else? The next is autonomous system, right? So it's gonna be 100, right? That has to match. So once we have put in the autonomous system, right, and there you see the adjacency has come up, right, because the autonomous system matched. And on the other side, though we have legacy mode, the adjacency does come up because the AS number is same. Okay, so the EIGRP adjacency has come up. You can also use the show command. You can say do show IPv6 EIGRP interfaces, and what do you see here? There's some little different behavior, right? In case of my R3, right, where we did the legacy mode, we had to explicitly go and enable it under the interface, and only then that specific interface was activated for EIGRP. But in case of R6, or basically in named mode, what happened is as soon as you enabled the address family IPv6, right, all the interfaces, right, got enabled with what? EIGRP, correct? And obviously, network, this might not be your use case, right? You wouldn't want to run routing on all the interfaces, right? And we'll see how to get around that. But this is the default behavior. As soon as you enable the address family IPv6, you can see all the interfaces, 00, 01, 02, loopback, everything got enabled with IPv6. There's another important command which normally network engineers use day in and out, especially with EIGRP, which is do show IPv6 EIGRP but topology, right? Topology, think of it as just an internal, it's basically the database, right, which has information about the best routes and so on, right? So this is a most very important command, and you can see right now in R6 what do I have? It just has all the local stuff. This is the loopback 0 of this IP is the loopback 0 of my R6, right? And then we've got what? Ethernet 0/1. We've got Ethernet 0/2, right? Basically all the interfaces of R6 are basically mentioned down here. All right, so let's proceed. Yeah, so we checked that out. Now what we do is so we have basically enabled it on R3, we have enabled it on R6, and we are also able to see some of the networks down here, which are basically exchanged between R3 and R6, and that's good. The next step is probably let's look at our topology, right? What else? We have R5 as well, so let's go and enable it over there, right? So let's do that. So let's get into R5. Okay, again, show CDP let's see the connections, right? This is the interface which we are interested with. So, but yeah, anyway, I mean, named mode does enable it for all the interfaces anyway. So, but anyway, let's get into router EIGRP. Again, I can technically use a different name here if needed, right? But I'm gonna still stick to using IPv6 only because I just don't want to confuse myself with many names. Address family is gonna be IPv6, right? We talked about this. IPv6 unicast, and the AS number is going to be what, 100, right? So as soon as I do that, you can see the adjacency coming up. This adjacency is established with the, you can see for adjacency it is using your link local address. That's interesting as well, right? Also, maybe I can show you that here. Did I show you the routing table, or maybe I'll show you that later? Okay, anyway, so we have enabled address family on where, R5, right? Let's look at the topology table here, okay? Because we know by default EIGRP is getting enabled on interfaces of R5. So do show IPv6 EIGRP topology. Okay, there you go. So what do we see here, right? So this is the topology table. Like I said, this is the, think of this as the EIGRP's database, internal database, which has information about, you can see this FD. FD is very important. It's nothing but your feasible distance. Right, let's pick a route, say, I don't know, maybe this route, right? So this route is basically the route between what? It is the segment between R3 and R6. If you go back to my topology, it's this segment, R3 and R6, right? And we are looking at that route where on my R5, right? So that particular route or that particular segment is visible here, and yeah, I'll not explain what feasible distance is, what advertised distance, and distances, because that's all basic EIGRP stuff. But basically, the FD or the feasible distances, this is the number, right? A huge number here, right? Now, this number is actually very useful for, basically it's the metric, right? The metric calculation in EIGRP, right? There is like a huge formula and all of that. Different protocols calculate the metrics in different ways. For EIGRP, it's basically the feasible distance, and, better the feasible distance, we are going to have that particular route will be selected and pushed to the routing table. Now, let's quickly have a look at one of the very important this thing, show command, another show command, which is do show IPv6 protocols, right? Because I want to show you something very interesting here, right? So you can see with respect to IPv6 EIGRP protocol, you can see what's happening here. There are two interesting nodes here. One is the metric version is 64-bit, right? So starting with new releases, right? The metric basically, there are two types of metrics, right? One is the 32-bit and the other one is the wide metric, which is the 64-bit, right? So starting with new versions, this is the default metric. So that's why, by default it is showing us 64, right? At the same time, in your legacy mode, right, which we enabled in your R3, right, legacy mode, here the metric will be your 32-bit, and I'll show you that. I'll kind of pro you that as well. Okay, so coming to R5, so you see the metric. This is something which I wanted to show you here, 64-bit, and there is something called as RIB scale 128, right? Now I'll tell you what this is, but before that, let me show you. Do show probably IPv6 route EIGRP, right? So these are the routes. Basically, where is the 36 route? See, this is the 36 route. The very first part is the admin distance. This is the admin distance of the protocol. For EIGRP, it is 90, right? That's very common. That's something which is well known. But what is this number here? 1536, whatever, this number. Now this number is basically that metric which we talked about here at the top, right? But you see it's different. Here it is something like 196, such a huge number, and here it's a little smaller number, right? So the thing is, when they introduce this wide metric, right, which is 64-bit, right, that metric doesn't really fit into the routing table here, right? So that's why, you have this RIB scale metric here, which is in this case 128. So you take this number 1968, whatever, this huge number, and you divide it by this 128, and that's how you get this number. This one 1536000, right? So that's how you get that. So because the wide metric system doesn't really fit inside the routing table, that's why we have that whole thing about Yeah, so nothing, it's a kind of like a nitty-gritty detail which I just wanted to call it out. Okay, so that being said, what else? We can also, I mean, if you do want, give me, okay, let's go to probably, I mean, if you I mean, this is really not recommended, but if you really want to try out, what you can do is you can simply say metric version, right? Technically, if you put a question mark, you will not even get that command, right? It will basically say not supported, but it's kind of one of the hidden commands, right? You can say metric version and you can say simply 32 and it still accepts, right? So basically now you have changed the metric on this router from 64, from the wide to this 32-bit, right? And this will take few seconds, but once, see, now it has reconfigured, right? So now what you can do is, if you run that same command here, again, basically the routing table, and you can see the numbers have changed. Earlier it was something like 150, 1536, whatever. See, the number now has changed, right? And if you go back and check the topology table now, you will see that do show route. Okay, I should have put EIGRP topology, my bad. Yeah, so do show IPv6 EIGRP topology. So you can see now the number 307200 is same as the number which is appearing in the routing table. So basically that whole division by the RIB, the RIB metric, right, which we talked about, the RIB scale, right? So that is not really necessary because this is not a wide metric anymore, and whatever feasible distance you see here is directly used inside the routing table, right? But obviously this is not really preferred. I mean, going forward, obviously that's why the whole metric system of the wide metric system was kind of like introduced, and it has a lot of benefits over this. So that's why it's not really advised to change it, right? So let's go back to using 64. So whenever you change it, it takes few seconds to reconverge and change all the metric values and stuff. But yeah, that should basically happen. And like I said, in your legacy mode over here on R3, the metrics which are going to be used are obviously the 32 bits, right? The legacy mode doesn't really support. You don't have any way to even change from 32 to 64 over there. Okay, so that being said, what else? So so we are good with that. So what we have done is we have basically gone and blindly, kind of gone and enabled your EIGRP on R3, R6 and R5, right? But now, like I told you, we have also ended up, especially on R6 and R5, because we enabled the named mode, we ended up enabling the EIGRP on all the interfaces, right? And that's really not needed. Like for example, on R6, we really don't want EIGRP on this interface, which is Ethernet 0/1. So let's see how to tackle that. So let's go to R6, enable. So if I do show IPv6, EIGRP and interfaces, you see we have it here, right? And we really don't want that, correct? And if you go to my routing table here, right, if I do show, okay, I shouldn't have gone out, but anyway, actually it's visible here only, right? See, in the routing table, in the EIGRP, or maybe we can just do show IPv6 route and EIGRP, you will basically see this route, which is 69 route, right? The 69 route is basically nothing but this route, right? 6 and switch 3 is basically considered as 9, so this route, this particular route, right? So as you see, that particular route has basically, kind of common to my R5 as well, right? Because it is enabled in R6 and from there it has come into my R5. Now how do we stop this? Pretty simple actually, right? So let's do that. So but then since I came out of the config mode, we'll have to get into it. How do we get into it? You can say router, grab this whole thing, right? Let's get into the config mode and let's go in. Okay, so once you're in there, what you can do is you can say address family interface. Which interface are we talking about? Ethernet 0/1, right? So let's grab that interface. Let's go in and we'll say shut, right? So you see this configuration basically doesn't go under the interface, it actually goes again inside the router EIGRP itself. That's why I've been telling in named mode, all the configuration, all the interface related configuration, everything goes inside router EIGRP, right? So that's pretty cool. So there you go, Ethernet 0/1, we shut it. So because we shut it now, if you go and if you go to R5 and refresh the routing table, you will no longer see 69, right? Earlier, see, you were seeing 69, now it is gone, right? So that's how you can remove an interface, and you can also basically run the same command here, right, which we were running. So we can basically go and say do run, there you go, right? We no longer have Ethernet 0/1. Okay, so that's interesting. Okay, so there's one more thing probably we can check out before we wind mainly the EIGRP section, which is passive interface, right? So let's go back to R6, and this time what I'm gonna do is, instead of shutting, I'm gonna do I'm gonna do a no shut, right? I'm gonna remove that shut which I had done, but instead I'm gonna passive the interface, right? So as soon as I did that, let's see what is going to be the difference here in the output of the show IPv6 EIGRP interface, right? There is no difference. Either I shut it or either I do passive interface. You see that interface will no longer appear in the it will no longer appear where in the interface table, EIGRP interface table. Let's go back to R5. What would have happened here, right? And there you go, right? So because I did passive, that particular route is back in the routing table. So when you do shut, what happens is the interface is removed from the routing table, and also the particular segment or the route is also removed. The prefix is also removed, and as a result, it's basically removed from the routing table, and EIGRP routing will basically not get that particular prefix. But if you make it passive, right? If you make it passive, it basically the prefix will still be reachable. Will be advertised, the prefix will be advertised, but the interface will be disabled for EIGRP, right? So this is a very common configuration of enabling passive, when you basically know for sure that that particular prefix, right, you just need it to be enabled for reachability, but you don't really want any EIGRP running on it, right? So that's important. So in my case, actually, since I really don't want anything in that particular segment, I'm gonna just do no passive, because I want to kind of put in some other routing protocol here, so I really don't want EIGRP here. So EIGRP, like I said, I just want it in this segment, which is R3, R4 and R5. Rest everything I want to remove it, right? So yeah, so I removed it from that no passive interface, yeah, if I keep it like this, again it will get enabled, so I'm gonna shut it, right? So once I shut it, it will basically, if I run this now, you can see it basically is enabled only for loopback to Ethernet 0/0 and 0/2. Wherever I require it, I've enabled it, and 0/1 I've removed it. Okay, what else can we do? Probably let's pick another interesting small example, which is what is the interface which is connecting, let's do show CDP neighbors, I think it is. If what is connecting R5 is Ethernet 0/0, right? So I'll do AF, okay, so I'll have to just exit out and then do AF interface, which is the interface Ethernet 0/0, right? So if I go inside that interface, what I can do is I can do lot of cool things, right? See, if I put a question mark, I can do a lot of configurations. See, I can set some timers. I can do things like summary address. We can try summary address, right? So I can do summary address, and I can put one default route. So what this does is, because of this now, if I go to R5, I will no longer see any of these routes, right? Let's do that. There you go, right? All these routes are removed, and one single summary address is being sent to R5, right? Basically a default route is sent to R5, right? So that is an interesting use case as well, right? Using summary address. Okay, so yeah, again, I don't want this, so let's remove that. I just wanted to show you as an example. Apart from that, what else do we want to check here? Probably the other thing is, let me just come back again, and here if I do AF interface, right? We were basically, once I put the AF interface, I was actually putting the interface name. But if I don't put the interface name, rather if I use something like default, right? And if I get into that and put a question mark, so all these configurations what you see, right, I can start doing it here and it will get applied for all the IPv6 interfaces, on that particular router. So that's a very good use case, right? I mean, if you want uniform configuration on all the interfaces, you can just do AF interface default. You don't have to do it individually per interface. You can just do default and come here and configure the hello time and passive interface or dampening, whatever, right? So you can go and configure all of that on all the interfaces just by doing default, right? You don't have to do it explicitly in each interface. Okay. I'm not going to do anything over there for now. Come out of this. There is another interesting thing, which is you might be wondering, if you're a core routing guy, you might be wondering how do we do things like redistribution and stuff. So those commands are under what we call as a topology base, right? If you put a question mark here, there you go. So you've got your things like redistribution and all your traffic share, and you want to do unequal load balancing and provide backup paths and all of that, maximum paths and all of that, those things you do it under the topology based configuration. Okay, so I think that's mainly what I wanted to show with the EIGRP, right? Just to sum this whole EIGRP discussion, what we can do is I'm going to show IPv6 route just to see if we have everything good running, right? So there you go. On my R6 we've got what? We've got the routes of R5. So this is my R5's loopback, and we've got the 52 and we've got the 45, right? So that's on my R6, whereas and all of these are learned via EIGRP, right? The same thing I can basically do on my on my R3 as well. Probably let's do that. There you go. So these are all the routes which are on my R3. On my R3C, it is able to reach R5, it's able to reach R6, and then the 52 and 45, which actually is something which I want to probably disable later if not needed, but just want to show you that all the routes are reachable and they are all showing up here, right? So that's how, again, I did not cover everything in EIGRP, obviously. I just wanted to give you a glimpse of mainly two things. One is your legacy mode versus your named mode, and what are the common kind of behaviors with either of those options. And then we played a little bit more on the named mode side, because going forward that's what we are basically going to be using, right? Named mode is a more better optimal way of configuring EIGRP. So we played around a little bit there, right? We tested a couple of configurations, we tested a couple of features, right? So hold on tight, we'll probably come back with more routing videos on IPv6. Two protocols till now, which is RIPng and EIGRP. In this section, we are going to actually talk about OSPF, right? Now, just a quick note here, between my R1, R2 and R3, I have put a small blue color cloud here, but that's just representing a DMVPN cloud, right? You don't have to worry about what DMVPN is, and I mean I do have a detailed series on DMVPN on the channel. Probably not a series, but I think there are a couple of videos explaining what DMVPN is. But you don't have to worry. We'll again probably talk about DMVPN in IPv6 later in the series. But for now, just think that there is a DMVPN, right? Which means there will be some tunnels which will be running between R1, R2 and R3, and we are basically going to enable OSPF over there, right? So in the DMVPN cloud, we are going to enable OSPF, and then in addition to that, we'll also enable it between R2 and R4, right, in this segment, between R3 and R4, right, in this segment, and the last one is between R4 and R5, right? So everything highlighted in blue is where I'm going to enable OSPF, right? And in this segment, which is completely to the left, in this particular section, we are going to use the area which is going to be area 0, right? So every segment here is going to be enabled for OSPF in area 0, whereas this one specific segment is going to be in a different area, which is area 45. Cool. With that information, let's jump on to the CLI, and other couple of important points here. Just like EIGRP, we have two different syntaxes for configuring OSPF, and we'll check them out, right? OSPFv3 to be specific. The other interesting thing is, OSPFv3, again, I'm not gonna dig deeper into the protocol, how it works and stuff. The basic understanding here is that you know at least the IPv4 version of the protocol, and we'll mainly try to understand with that as the starting point, and how OSPFv3 is different from, or what are the various changes with OSPFv3. That being said, you can technically run one single protocol, which is OSPFv3, in your network, and it can support both your IPv4 and IPv6, right? Whereas your traditional OSPFv2, you can run it only for IPv4, whereas your v3, you can actually run IPv4 over the OSPFv3. It would still need IPv6 for the transport, but you can actually have just one protocol and do everything with it, right? So that's a good thing about v3. So if you have like a dual stack or a multiple, if you have v4 and v6 in your network, you can explore that. That being said, let's get into the configurations, guys. So let's start with what? R1. So let's jump onto my CLI here. Okay, so what do we have? Okay, so this is R1, right? So let's first look, show CDP neighbors. So that's what we have. From R1, I just have one physical connection to R3. But like I said, I have told you that I have a tunnel running, right? So if you see show IP interface exclude unassigned, right? I basically, okay, the tunnel is not showing up, but show interface tunnel, I believe there's a tunnel 0, right? So there you go. So that's tunnel 0, which should technically show up in show IP interface brief. Yes, it is. Okay, so there you go. That's the tunnel, right? That's the DMVPN tunnel, and the same tunnel is going to be there where it's going to be there on all my 3 routers, which are part of the DMVPN, right? So there you go. We have tunnel 0 here as well, and we should have it over here as well, right? For your understanding as of now, just think of tunnel as any other physical interface, right? Don't worry too much about what is tunnel, what is DMVPN. We are just going to enable OSPF, just concentrate only on the OSPF part. We will talk about DMVPN and stuff later in the series. Okay, so coming here, let's go and try to enable OSPF here, right? So how do we do it? Let's get into the tunnel 0, right? And the configuration, this is the legacy way of doing it, right? This is the older way of doing it. So I'm gonna say IPv6, then put in the protocol OSPF1. Then we'll have to give the process ID of the OSPF, right? Let's put a question mark, and we'll have to give the process ID, which is in our case 1, right? We're going to use OSPF 1. And what will be the area? The area, like I said, it's going to be 0, right? For the DMVPN cloud, right? So there you go. Once I do that, I can go and check do show IPv6 OSPF interface probably brief, and there you go. That gives information about that OSPF just got enabled on tunnel 0, and you see the status point to point, right? We'll have to do a little bit of changes later, but for now, yeah, it's point to point, right? You do know that OSPF can run in multiple modes, right? Multiple modes. You can do it in point to point, or you can do like a broadcast network where you have your DRs and BDRs and all of that. So there are different such modes, right? And point to point is just one of those modes. Okay, let's also take our loop back and kind of advertise it in the same OSPF process, right? So we have done that. Let's actually go and quickly do this for the other two guys as well, right? So tunnel 0, and let's put it in this thing. Okay, IPv6 routing not enabled, so we'll have to enable IPv6 before we okay, let me just get out of here. Set IPv6 unicast routing, right? Now let's get into the tunnel 0, and let's enable this and loop back 0 as well. There we go, that's done. And you can see the neighborship is coming up with R1, right? You can see the neighborship, which is 10.1.1, which is my R1. That's good. Same thing, let's come to R3. Probably let's enable this if this has not been enabled, and interface tunnel 0. Let's enable IPv6 OSPF 1 area 0, and interface loopback 0, and let's do the same thing which will be here. Cool. And you can see R3 also is setting up its neighbor. The neighborship adjacency is trying to come up with what? It is trying to do it with R1 again, right? Because it's a DMVPN tunnel, right? So in the DMVPN tunnel or DMVPN setup, what I have is I have my R1 as the hub, and these both are the spokes. So R2 is trying to set up a tunnel, trying to set up adjacency with R1. R3 also is trying to set up adjacency with R1. So that's why you see that. Okay, cool. So now let's see what's happening. So let's probably get to say R2 and let's see the routing table. So if I do show, because the adjacencies are all set up, let's see what's going to happen. Do show IPv6 route. Sorry, I made a mistake. Do show IPv6 route. Which protocol? OSPF. And we are seeing that it is getting the loopback of R1. Okay. So, but it is not getting the loopback of R3. Okay, interesting. That's all because it's in the DMVPN setup, right? So we might have to do a little bit of changes, right? Let's actually see why that is happening. If you probably do something like let's see the LSA, right? You know the LSAs, which are basically, there are different type of LSAs, right? Type 1, type 2. So let's check the type 1. So if I do show IPv6, probably OSPF, database and router. So that's the router LSA. And see, the problem seems to be that what we are trying to do is, so this is the advertising router, which is R1, this is R2, and there should be R3. Okay, R3 as well, right? And you can see that we have a line which says LSA ignored in the SPF calculation. That's why we are not getting any information from R3. The reason is, what's happening is we have set it up as a point-to-point OSPF, but then what is happening on R1, you see, it is, in a point-to-point you just have what, 2 neighbors, right? You have just 2 peers on either side of the wire. But what's happening is R1 is seeing two neighbors. It's seeing 2 peers, right? It's supposed to see 1 peer, but because it's a DMVPN setup, it's a multi. What is DMVPN, right? It's just nothing but multi-tunnel, right? Multi-point tunnel. Because of that, it is seeing R2 and it is seeing R3, right? And whichever is coming first, it is accepting, and the other one, it is dropping. So the quick fix for this would be to kind of, because without fixing this, what is going to happen is we are gonna lose out on routes, right? What I mean is, if I probably go to R1 and if I do show IPv6 route OSPF, and you can see I just have the loopback of R2, right? And we saw on R2, I think we were getting just the loopback of R1, and on R3 I think we'll not see anything. Do show IP OSPF, IPv6 route and OSPF. You see here, there's nothing, no routing table at all. There's no routes coming from OSPF, right? So a quick fix would be to probably change the tunnel, right? Change the network from point to point to say something like point to multi-point, right? And that should fix it. So what you can do is, this is the hub, right, where the DMVPN hub setup is there. So we can go inside the tunnel 0, and what we can do is we can do IPv6, say OSPF network and point to multi-point, right? By doing this, what we are telling is, look, you are not supposed to have just 1 neighbor, you are supposed to have 2 neighbors, because it's a multi-point now. 2, you can have not just 2, more than 2, but in this case it's just 2, right? So once I do that, I think this should get fixed. Also, there should be one more thing. We need to also fix the hello and dead timers, right? Because when you make such a change from one type to other, one network type to other, there would be those things will not exactly work if the timers are not synced. So let's check that. So what we'll do is we can check that. We can do show IPv6 OSPF interface tunnel 0, right? So what is the OSPF details for tunnel 0? You can see the hello timer and dead timer is 30 and 120, right? Because of this change to point to multi-point, you can see it's 30 and 120. Whereas what is it going to be over here? Show IPv6 OSPF interface tunnel 0, right? So it's going to be 10 and 40. So you see there's a discrepancy. Let's change it everywhere, right? Pretty simple to change it. You just need to get to the tunnel 0. In my case, I'm already on tunnel 0. I just need to do IPv6 OSPF, right? I think it's hello timer, yeah, hello interval, right? And change it to say 1, right? 1 second. So when you change the hello interval, the dead interval automatically gets changed because it gets multiplied by 4, right? So we changed that here. Let's see if we can change that in R2 as well. So let's get into R2 interface tunnel 0. Let's change it here and here. Okay. Sorry, did I do it at the wrong place? Probably I did it at the wrong place. Let's not do it here. You have to do it in the tunnel, right? So let's go to tunnel 0 and do it here. All right, so let's see now if everything is synced, right? So if I do same thing, show IPv6 OSPF interface tunnel 0, you can see the hello and dead interval has changed to 1 and 4, right? Same thing should happen on here, right? 1 and 4, and the same thing should happen on here. So that's how simple it is to, you know, kind of go and change this timers, right? Let's check here as well. Right, 1 and 4, cool. So with that fix in place, right, because we have changed it to point to multi-point and we have changed all the timers, now all the routers should be getting the OSPF routes, right? We can check that. Do show IPv6 route OSPF, and there you go, right? So we are getting on R1, we are getting the loopback of R2 and R3. The same thing should be valid on these guys as well. So if I do here, there you go, we are getting the loopback of R1 and R3, and also the network, which is basically the cloud, right? The DMVPN cloud, right? That this whole network here, the whole image which I drew, right? This whole segment, that's that particular prefix, right? So we are getting that from R1, and that's why you can see that network is over here. The same thing should be true even for what? It should be true for R3 as well. There you go, right? We are getting R1, R2 and the cloud. Perfect. So whatever we did worked, right? We enabled OSPF on all the 3 routers. We are able to see the loopbacks showing up over there, right? We enabled it on the tunnel interfaces and the loopback interfaces, and we are able to see all of that. Cool. Let's come back to our task. What else should we do, right? So we need to also go and enable between R2 and R4, R3 and R4, and R4 and R5. So let's get to that. So where is my R2? Okay, so do show CDP neighbors. Connecting to my R4 is this interface. So let's get into that. And once I'm inside that, what I can do is I wanted to show you the new way of configuring, but let's do it on another router probably, right? So this will be OSPF1 area 0. And what is it connecting to? Ethernet 0/2 on R4. So let's come here on R4 and let's enable conf, right? Get into the interface and do the same thing, which is IPv6 OSPF 1 area 0. Okay, so we have done it between, or we enabled it on the segment which is R2 and R4, right? So within few seconds you should start seeing the neighborship come up between these guys. Hope I did it on the right interface. Yeah. Let's see. Show CDP neighbors here. That's R2, and what about here? Show IPv6 OSPF neighbor. Yes, okay, it's trying to come up. See, it's in the two-way. Okay. So it's going to come up, right? While it is going to come up, let's do between what? R3 and R4. Okay, there you go. The neighborship is up. Cool. So between R3 and R4, we have to see what is the interface. So R3, it is connected to Ethernet 0/0. So let's get into that interface. Okay. So we'll get into that, and maybe what we are going to do is, give me a second. Yeah, so on R3, okay, let's do the R3 R4 segment. So on R3 again, if I do show CDP neighbors, you can see the one interface which I'm connecting is this one, so I can get into that interface. And how do we do the old way of doing it? IP OSPF1 area 0. Pretty simple, right? Now on the R4 side, did I use the old way of doing it or the new way of doing it? Oh, I used the old way. But I do want to show you the new way, so let's redo this one, right? So let's get into that, right? I want to show you how to do the new way on this router, new format, right? So I'm gonna just remove this, remove the old configuration, right? And let's do this again. So how do you do the new format? For the new format, you write OSPFv3 and the process, right? And then which protocol, IPv4 or v6, because like I said, it supports both, right? So in my case, I'm right now working on IPv6, right? And then the area 0, right? This was for the old interface. Even the new interface, which is Ethernet 0/0, which is connecting my R3, right? The same thing is going to be applied, right? Everything is in area 0. Okay, so we have completely finished with area 0. Now let's do the area 45, which is connecting what? 4 and 5 over here, right? So let's do that. So what is connecting 5? It is the serial interface. So let's get into the serial interface, and the only difference is we're going to grab the same command. Only difference is instead of area 0, we are going to say area 45, right? Pretty simple. On the other side as well, which is on R5, we can get into the serial interface serial 1/0, right? Same configuration, except the area is going to be that only, which is area 45. The area should match, right? Otherwise the neighborship won't happen or the adjacency won't come up. Okay, so there you go. So we have actually set up kind of whatever we wanted to do. Now if you have done everything properly, when I go on R1, we should see what? We should see some O routes, right? And we should also see some OI routes, which is inter-area type 3 kind of routes, right? Let's check that. So earlier, see, we just had 2 routes, which are just O routes, but now we should see quite some more, right? There you go. So maybe okay, so probably there's one more thing we can do is on R5, I can actually go and enable it on the loopback as well, just to see, if this is really coming up. So let's also enable it on loopback here. Okay, so once I do that, let's refresh here, right? Within a few seconds we should see one more route as well. Right now you can see it is showing your R2, it is showing your R3, right? And then it is also showing the segment, which is R2 R4 segment, right, where we enabled it between R2 R4. Then it is also showing the 45, which is the R4 R5 segment, right, which is the serial interfaces. Only one more is we have also enabled it on the loopback of R5 just now. So there you go. I think that is also visible, and you can see the difference OI over here, right? So the OI basically is that OSP of inter-area routes, right? Whereas just the OR basically the routes corresponding to area 0, right? So pretty simple, pretty straightforward, just like how we have our regular IPv4 OSPF. Now the next couple of minutes, right, or probably a little more than a couple of minutes, we'll talk about one of the most significant change with the OSPFv3, which is the OSPF LSA database, right? How it is different from your traditional v4. Yeah, so one of the main differences with let's come back here, right? So one of the main difference, if I have to write it down quickly here, is that in IPv6 or in OSPFv3, what they have done is the topology information, right? The topology information of OSPF, and what is the other one? Prefixes, right? So you have your prefix, right, which is kind of advertised inside the LSA, right? So these both they have tried to separate. Right, and that's one of the most significant difference. So we do get to see this very evidently, and they have introduced 2 more LSA types, right, which is LSA 8 and LSA 9, right? So we'll actually get to see that and we can just explore that as well, right? So those are the couple of, I mean, there are other changes, minor changes, but these are the major, kind of changes with OSPFv3, right? How do we check that? So right now, if you see, right, on my R1, I actually have OSPF running on both v4 and v6, right? I have not shown you the configuration of v4, but just assume it is there, and we are going to use that to kind of compare the compare the changes, right? So if I do show IPv6 OSPF and dump the whole database, this is the complete database of IPv6, right? This is how the database looks. You will see that this is your type 1, right? This is your type 2, you've got your type 3, maybe the name has been changed a little, right? Because you see normally type 3 you would probably see something like summary prefix or summary LSA or something, but here they have changed a little bit, made it more easier. And then you see type 8 and type 9, right? These both are new LSAs which were not there in v4, right? You can actually see the v4 table just by removing the 6 here. Sorry, made a mistake. We show IP, let's remove that. Yeah, show IP OSPF database. Now that is showing you nothing but the v4 one, right? On the v4 you can see you don't have type 8 and type 9, you just have here router type 1 and type 2, and then obviously you have type 3 and 4 and 5, depending on if you have your external routers or not. But if you want to really see the difference, what we need to do is we need to dig a little deeper. So let's get into the type 1 LSA, which is show IP OSPF, right? OSPF process is 1, database, and what is the type 1 LSA? It is the router LSA, right? So let's get into that. And when you see here, what do you see? This is for IPv4, right? And you can see one of the important thing here is when you're sending the LSA, right? In that LSA, you also advertise the subnet. You can see this is the subnet. This is the loopback of R1. So that's been sent. Loopback, right? Address. This is basically who is advertising it. But every single, you can see here 10.2.2 and 255. So every single LSA, basically, especially if it's a loopback interface, right? Think about this scenario where imagine you have a loopback which is flapping on your router, right? Or maybe, loopback would not flap, but imagine someone shut the loopback down or something, right? You're testing something and you did a shut, no shut, whatever, and because of that the whole SPF algorithm has to be recalculated in the OSPF, right? And that is going to do a lot of changes in the OSPF area. That's going to create a lot of churn on the routing table and so on, right? Which is not very much desired. Okay, so in OSPFv3 what they have done is they have tried to separate the topology information from the prefix information, right? So which was not there in v4, and we can check that, right? So in v4 you can see the topology information, and your topology information is basically nothing but this, right? Who is connected to what is the router ID, right? Who are your neighbors? In this case, if you go a little bit top here, and you basically see that these are all your neighbors, right? This is me, this is 10.1, this is R1, but you can see neighbor ID is this one, this is R3, this is R2. You can see the whole neighbors, you can see the metric, you can see the topology information, but then you can also see the whole, you can also see the prefix along with it. But let's see the counterpart of v6. Let's just change this to v6 here, and you can see the difference here, right? You can see a very clear difference. Let me just, yeah, so you can see a clear difference, right? If you get to any of the LSA, like probably this is, we are looking at the type 1 LSA, and you can see this segment here, we are not giving any prefix information, right? So type 1 is now providing just information about the topology. It is just telling that this is my neighbor, right? This is my neighbor interface ID, this is my local interface ID, this is the metric, right? And that's it, right? There is no prefix, right? Similar is the case with type 2, right? So if I, how do you see type 2? Just come here, change this router to network LSA, and that will give you type 2, right? I'll not explain what type 2 is, which you should know probably if you know OSPFv3, v4 already, or OSPFv2, sorry, you know your IPv4 OSPF, right? But you can see here, even in this one, we don't have any information about any prefix, right? So what they've done is type 1 and type 2, they have reserved it only for giving topology information, whereas you know, if you want, if you really want that prefix information, it is basically bundled into type 8 and type 9, right? So you can do same thing, show IPv6 1, or just say OSPF and directly do database, it will show for everything, and then you can do link, right? That will give you the type 8, right? But what is the difference between type 8 and type 9? Type 8 will give all those networks, right, which are to which all those networks between me and my neighbors, right? And as a result of that, loopbacks will not be part of this, right? So you can see here, what are my neighbors? If you from topology, if you remember, my neighbors for R1 are R2 and R3, because they are all part of the DMVPN cloud. So you can see this one LSA is originating from R1 itself, right? And it is telling this is the prefix which is connected, right? This is the prefix of the DMVPN cloud, right? And then there is a LSA arising from R2, and it is also advertising the same prefix because it is also part of the DMVPN cloud, and just the other one which is coming from R3 and the same prefix, right? So all the other prefixes from each of these routers are not shown here because those prefixes are not kind of shared, right? They are not between the neighbors. They are there, yes, on that router, but they are not between these neighbors. So type 8 is mainly for that, right? Type 8 will have the prefixes, you know, of the networks, you know, with my neighbors, right? As a result, even loopbacks won't be here. But if you want to get all the other prefixes, you just need to go to type 9, and that's basically can be seen, show IPv6 OSPF database prefix, right? And that will have all the other prefixes, right? So it will have, say, this is the loopback of loopback, and this is the loopback of R3. You can see there is something called 24, which is the segment connecting between R2 and R4. So all the other, you know, prefixes are going to be part of this one. There is some very, very main difference. Okay. Apart from that, so we talked about what? We talked about type 1, type 2. We saw that, you know, we saw the changes where they have removed the prefix information. They have retained only the topology information. We also talked about type 8, type 9. Just to get a closure around this topic, we can also just have a look at what type 3 also, right? We can do type 3. I would say not much has changed with type 3, right? Because it's very same as your IPv4. You have show IPv6 database, but I think the name has changed. So here it is basically called inter-area prefix, right? And then you can get the information. You can see we just have only one other area, which is area 45. And this is the prefix coming from that, right? Because type 3 is all about what? Inter-area summary. You know, it's nothing but summarizing the database and, you know, summarizing the OSPF database and sending it to other area, right? That's your type 3, and that's why you can see this information about the other area showing up here. Okay, so that's type 3. And type 4 and type 5, we really don't have a ASPR right now, right? But still, you can see the commands which is show same thing. It's just that you change this database inter area, but for type 4 it is going to be router, and for type 5 it is going to be what? Database and external, right? Right now you see there is no information in that because we really don't have you know, type 4 and type 5. Type 4 and type 5, they are like a, you know, kind of like a pack, right? They are like a bundle, right? If there is type 5, then you'll have type 4 as well, because you'll have an external router, because of which you'll have the ASPR summary and then the ABR summary. But in my topology right now we don't have it, so that's why it's empty, right? So I think we kind of covered all the LSAs, right? Talked about type 1, type 2. Then we also had a look at type 3. Type 4, type 5 is not very relevant in this discussion at least, but we saw the show commands to get them. And then we jumped on, looked at basically type 8 and type 9, because those are the new ones, or the newly introduced ones in OSPFv3. Okay. So that was mainly OSPF. Again, there's a lot of things around redistribution and stuff which, if time permits, we'll cover later in the series. Okay, cool.